Hi, welcome to the Mentored Engineer. In this video, we're going to look at instrumentation and retrofitability of machines for IoT purposes. Welcome back, Clay. We appreciate you sharing your time with us. And this video, we're going to talk about retrofitability and what type of instrumentation we should put on IoT devices. Okay, so looking back at on old device, how do we know whether or not, let's just say, it's a device that has some sort of data acquisition on it, and maybe even a SCADA system. Should we convert that to an IoT device, or should we just leave it alone and continue on our way?
Yeah, absolutely. So it's something you want to think about ahead of time. So you want to sit down and look at your machine. Is there something additional or something we're missing that I'd like to monitor for my machine? And if so, is there an easy way to do that? A lot of times there is with the the number of sensors that we have available in the marketplace today. So you may look at that device that may be hooked already into a system existing, or it may not be, and you can decide what you want to monitor and if that data will help you. If that's the case, then it's definitely worth having an IoT device connected to it. That way you can pull that data, make decisions, make changes after you analyze it.
Okay. And what is the major benefit, even if you only have like a sensor that tells you, I'm on?
Yeah, absolutely. So an on-off is a great example because think of motors, pumps. If they run for too long, they'll wear out. It reduces their life cycle. So somebody, let's say in a water lift station, may want to know if their pump's been on for too long. Let's say they don't want to run them more than 6 hours. They would like to have an alert say, hey, your pump's been on for 6 hours. It's been raining a lot, causing flooding, and it's been on for too long. So they may want to switch it to a backup pump, go turn it off. That's great information for them so they don't burn their pump up.
Mm-hmm. Another thing with pumps or any type of motor is you don't want it turning off, turning back on, turning off, turning back on. Those will damage it too. So you can also measure and manage that as well, right?
Yeah, absolutely. So you can manage the cycles. You could have it set up to run for a signified amount of time, or you can have it set to where, hey, you get an alert, your pump's running, so you can keep an eye on it and make sure it stays on and turn it off after a certain amount of time.
So Clay, we know that the Sealevel system here has a bunch of inputs and outputs and can accept a bunch of types. But when you're planning out a system, what kind of things do we not think of that should be monitored, that could be monitored, that we just don't appear right away?
Yeah, absolutely. And that's something as you start digging into IoT, you start realizing, hey, I can monitor this or I can monitor that, and you didn't think about that before. I know a good example is a company we work with monitors road signs for businesses. So you think like your McDonald's, Holiday Inns, big businesses like that. They want their signs to be on and to look good, look professional, and they go out from time to time. We've all been riding down the road and seen their sign halfway on, and that really reflects poorly on the business. So they have a system where they connect with one of our devices to monitor those signs to make sure that they're still on. That's one thing people maybe not think about monitoring the signs. Previously, these companies would pay individuals to drive around all day and look at their signs, make sure they're on, things are spelled right in that regard, whereas now that's taken care of. All right.
Clay, do you ever use signal conditioning devices in your systems?
Currently we don't. I've not run across that personally. Not to say that it hasn't been done or can't be done, but in my experience I haven't seen it. But again, that is something that definitely I see from an IoT standpoint as being potential to be used with our devices.
Okay. And just for those of you who don't know, a signal conditioner is a device that you'd put between your instrument on the output side, and then it would convert that data to work better with the Sealevel system. So for example, if I have a device that uses a strain gauge and it has a millivolt output, and the Sealevel device is a 0 to 10 volt input, those aren't going to pair well. You're not going to have good resolution. So a signal conditioner would go between the two and transmit the data from millivolts and convert it into the 0 to 10 volt system. Other applications would be to filter data. If you have a 60 cycle hum in your instrument, you could filter that out using a signal conditioner. Okay, so let's talk about video for a little bit. Video is going to be, I think, where IoT goes in the future, where you can have, basically real-time streaming of video, whether it be in the visual spectrum, the infrared spectrum, or even just thermal imaging. Can you shed some light on that?
Yeah, so currently as we are now, we're in 4G, LTE, moving towards 5G. The capability for live streaming data, or live streaming video rather, is not quite where it needs to be yet. I foresee that as something coming down the pipeline in the coming years as that infrastructure gets better and better and as systems improve. I see many applications for video, whether it be for emergency management, monitoring certain locations, or even thermal imaging of a machine from a remote location. Really, again, the sky's the limit in that area as far as if you can figure out something you need physically or visibly monitored, you could use an IoT device once the technology becomes available.
Okay, so building on that a little bit, since the technology isn't there, is there a way to use IoT to interpret what the video is seeing? If you're looking, say the thermal image, if you see something that's too hot or too cold, can you do that right now without having to transmit that to the cloud?
So there are a few ways to do that. It's sort of a roundabout ways. You could use a temperature sensor instead, or you could potentially have some sort of optical reader on your end, on the device end, that takes the data, looks at it, and sends it to the cloud, and the interpretation is done on the back end. Again, with the connectivity, it's just not quite there yet, but I do see that's something in the future that just definitely grows from where it is today.
Okay.
So additionally to our capabilities today, this is something that we're expanding to here at Sealevel is more of edge computing, or on the edge, as some people call it. So basically our 370 device will have more capability to do onboard computing without sending data to the cloud. So if you have an automation you need to have, you don't necessarily want that controlled at the cloud level in case there's an interruption. So with on the edge devices or edge computing, you can make decisions, have if-then scenarios on the device that happen regardless of the data sent, and then the data is pushed to the cloud once the connectivity resumes. So that's a wonderful way for automation type systems, things that can go wrong if you lose connection.
Okay. So thank you for joining us, Clay. We appreciate your time, and we hope this was informative to you, and thank you for watching The Mentored Engineer. Thank you for watching this video. Please visit us at www.mentoredengineer.com so that you can stay abreast of the newest happenings in mechanical engineering. And we ask that you subscribe so that you can always be up to date.